If you remember back when we were solving exponential equations, like if we had 3 to the x is equal to 3 to the 5th power, then we would know that x has to be equal to 5. So if you remember, when the exponents, or when the bases are the same, then the exponents have to be the same. Okay? Well, the same thing goes for when we're solving log equations. If the log of x is equal to the log of, let's say, 5, then we would say that x is equal to 5. So it's the same kind of thing. When the bases are the same, and these bases are the same, log base 10, then the arguments have to be the same. So that's one thing we're going to be thinking about while we're working through these examples. The other thing we're going to be thinking about is the function y equals the log of x. When we think about the log of something, the log is an exponent you have to raise the base to get to the argument. Well, that exponent has to be a positive number, the argument has to be a positive number, because when you raise a base to any number, it has to be a positive number. So keep in mind that whenever we're solving these kinds of equations, logarithmic meaning, the x that we get, or whatever the argument is, has to be positive. And so we want to always check for extraneous solution. Check extraneous solutions. Check for extraneous solutions. So that's a really, really important concept to remember. Okay, so always, always, always check for extraneous solutions. So let's go ahead and get started. So problem number 1, the log base 6 of x plus the log base 6 of 3 is equal to the log base 6 of 12. All right, so when we're solving this equation, we should notice here that we currently have all the terms have a log in them. So therefore, we can just combine the two logs on the left-hand side into one. So we have the log base 6 of x times 3. Now we could write it as that, x times 3, or we could write it as 3x. And that's equal to the right side. Don't have to change anything on the right. Log base 6 of 12. So therefore, since the bases are the same, we have a log on one side, log on the other. And that tells us that the arguments are allowed to be the same. Must be the same. So we have x is equal to 4. And that's it. And again, we always want to make sure is that number that we got, is that solution that we got, are we allowed to plug that back in? So 4, yeah, log base 6 of 4, that's okay. And we don't have any other variables in the other logs, expressions, so we're good to go. And then the next example is the log base, what is it? Okay, so just log base 10, so we don't have to write the 10. Log of x plus 1 minus the log of 3x minus 2, might not have left myself enough room here, equals the log of 3. And we notice that we have the difference of logs. And so, again, a couple things too. We notice that every term has a log in it, and in this lesson, every term will always have a log in it. So that's going to relate to just combining the logs on one side and then equating the arguments. So here we have we have the difference of logs, and so we're going to write that as the log of the quotient, log of x plus 1 over 3x minus 2 equals, and we don't change the other side, just equals the log of 3. And again, we're going to hear this over and over again. The logs have the same, so we have one log on each side, has the same base 10, so therefore the arguments have to be the same. And the argument on the left-hand side is an x plus 1 over 3x minus 2. On the right-hand side, the log is just, the argument is just 3. And now we have an equation that we can solve. If we remember, we're going to go ahead and multiply both sides by 3x minus 2. And then when we do that on the left-hand side, we do that because we can get rid of the fraction on the left. We just are left with x plus 1 on the left. And on the right-hand side, we're left with, now we can just go ahead and distribute this at the same time. 3 times 3x is 9x. 3 times negative 2 is negative 6. Now, if we subtract x from both sides, we're going to get an 8x on the right-hand side. So we subtract x from both sides. And then we're going to go ahead and add 6 to both sides. Add 6. So we get, on the left-hand side, 1 plus 6 is 7. I'm kind of shaving a couple steps here because I'm running out of room. But if 7 is equal to 8x, then we divide both sides by 8. And after dividing both sides by 8, we get that x is equal to 7 over 8. And we always want to check 7/8. So can we put a 7/8 plus 1? Yeah, that's still a positive number. Now this is a little trickier. 3 times 7/8, that's going to be 3 times 7/8. That's 21 over 8. 21 over 8 is greater than 2. And so anything greater than 2 minus 2 is going to give us still a positive number. So, positive number. So 7 over 8 checks out. And now for the last example, here's what I want you to do. I'm going to write it down. And since we're already at the 6-minute mark, I'm going to write it down. And then I want you to go ahead and try this one on your own. So example 3, log of x minus the log of x minus 1 equals the log of 5. So again, pause the video, write it down, pause the video, and then when you finish and you get a solution, go ahead and check your solution with, just run the video and check your solution.